that is within 0.00001, I can't remember how many zeros I said, of the actual value. Now the first thing you have to do is find a Taylor polynomial for cosine x. Right? Really it's a Maclaurin because we're going to center it at 0. So take a minute, find a Maclaurin polynomial for cosine x.
How many terms?
Infinite?
However many you feel like, and put a dot dot. I'm not going to make you write infinite many terms. You put a dot dot dot.
So okay, is that 2?
I think so. I would go 3 or 4. Come on, you can do a couple.
Well, it's cosine, so isn't it going to be like alternating?
Yes, it will.
So you can do 4, but get away with only 2 things.
So I found the first 4 derivatives when I was doing it. Did you get a polynomial? Looking something like that? Good. All right, we want our approximation at 0.1 to be within 0.000001 of the actual value, right? So the first, this is the cheat way. I'm putting this on tape so I can't take it back. Okay, so the first thing I would do is find what the actual cosine of 0.1 is, right? So plug it in, write it down. Got it? Now, we have to plug 0.1 into our polynomial, right? So all I do is plug 0.1 in and keep adding terms until my value is within 0.00001 of what I got for the cosine, right? So it's cheating, but there's nothing technically cheating. I mean, it's mathematically solid, so it's the way to, if like the formula is making you crazy and you're like, oh gosh, I know I can just do this by doing it, right? Then it's another way to do this type of problem.
It's not like
You have to do it anyway. I mean, you're going to have to plug into the polynomial anyway for the actual problem because the question said to find the actual approximation. So you do have to find the approximation. There's no way around it. So this one, no way. This one is off by 0.000. Oh, well, I guess you could say that that's true. You could kind of really go with the second degree. I kept going. I need to add another 0 or 2 in here to make sure that it gets all the way up to the 4. So I found p sub 4 was the best for doing this one. Bingo.
Seems so much harder.
That seems harder?
Yeah.
Well, I gotta tell you, you're using the remainder formula just to, you'd have to do it just to find n, and then you'd still have to write your polynomial and plug the 0.1 into it up to n terms, right? So it's no harder, it's just different. Okay, so here we go. Can you approximate the remainder of a polynomial? Yeah, good. Can you determine values of n to create a polynomial with a remainder less than the given value? Good. And can you determine values of x for which a given polynomial has a remainder less than a given value? Of course. Of course. Yay, good.